Electric shock is a serious safety hazard. Accidents involving electricity can cause shock, they can cause burns, possibly even death. Obviously a topic that you need to pay attention to in your safety curriculum and your safety training. What are some of the most common electrical safety problems that occur and some of the guidelines? First of all, and probably most important, any circuit that is in a laboratory setting where there is water or ground, such as a sink, a faucet, a gas outlet, and so on, those circuits must be protected with ground fault circuit interrupters or ground fault interrupters, GFCI or GFI circuits. What those do is they detect any difference in the current between the hot line and the neutral line, and as they can respond to that difference in current, which would occur if there were a short circuit, in as little as 25 milliseconds. And they can detect a difference in current of as much as 5 milliamps, actually a little bit less than 5 milliamps, that's the upper limit. So that's the most important safety guideline for your electrical outlets in any laboratory, certainly where there is water and gas outlets and so on, so any laboratory really. Secondly, you need to inspect your circuits at least yearly. In a recent inspection that we heard about at a local high school, they found that 30% of the circuits were wired improperly. There is a small device that you can purchase, which is called a ground fault circuit interrupter tester, a receptacle tester. And this will detect up to 6 different possible combinations of improper wiring in your electrical circuits. And that's a very, very common error that is found in laboratories across the country. So we urge you to check those at least yearly to make sure that things are wired properly. Obviously, if there are any scorched outlets or so on, those need to be repaired immediately. Electrical cords. A variety of equipment is present in the physical science classroom, the chemistry, the biology room. In the biology lab, you have electrophoresis apparatus, power supplies associated with that. In physical science, Van de Graaff generators, static electricity, but nonetheless hazards associated with that. We have a special publication for Van de Graaff generator safety that's available on the website for this laboratory safety course, and we urge you to download that, print it, and follow all of those precautions for working safely with Van de Graaff generators. In the chemistry classroom, when you're studying the properties of gases, their spectroscopic properties, emission spectra, and so on, you have high voltage power supplies. Very, very important to obviously follow all of the manufacturer's directions for any electrical equipment that you have in the laboratory. So for an electrophoresis power supply, for the spectrum tube power supply, and so on. When working with any of these equipment, it's very important that you not produce a trip hazard from the cords, so that if this cord were hanging down in front there and students were walking by there and there were an outlet on there on the outside of the table, that would be bad. Where do you get common trip hazards? Hot plates. Hot plates, magnetic stirrers, and so on. One of the things that we do in our lab is we actually wrap the power cords around the table legs, if you can do that, and whatever might work. But certainly you want to look with fresh eyes at all of the electrical power cords and outlets in your lab and make sure that you don't have any trip hazards there. Almost all laboratory equipment should be a 3-prong plug with the ground. And so you want to look at your equipment and look at the prong and make sure that you have that grounded plug there, here on the spectrum tube power supply that we do, and also on the Van de Graaff generator. When you remove the power cord from the outlet, you don't want to obviously touch that at all, so you want to remove it here, obviously not have wet hands or anything like that as well. So make sure your hands are dry and always pull it out by the plug out of the outlet. You shouldn't use really any multiple outlet bars or power strips that you might have at home and something like that to plug in more equipment. If you need to do that, you need to make sure that they have fuse protection or a circuit breaker, but we really recommend that you not use those in the laboratory. Some general rules when working with electrical equipment: keep the area dry. That's especially true for something like electrophoresis in the biology lab, where you have a buffer solution in there, you have gels that are stored in a buffer solution, you're moving it and so on. You want to wipe that area clean. And you know, it's a good idea now to talk about the fact that you review all of the safety precautions before doing any lab. And you do that with chemicals, you do it with electrical equipment as well. So just a reminder to start with safety every day, every lab, every lesson, and so on. It's a good idea, if possible, and we know that in some labs this isn't possible, the teacher should know the location of the electrical cutoff switch so that power can be turned off in the lab. Very, very important, if you're working with electrical equipment, be mindful of anything else that's in the lab. In particular, sparks from electrical equipment can, of course, ignite flammable vapors. So, again, following the safety rules for working with flammable liquids in the laboratory: never use flammable liquids if there are flames, heat, sparks, sources of ignition. That would be a very bad thing. If water is spilled in the area around electrical apparatus, immediately turn off the power. So if you have an on-off switch, you should immediately, and you should always have an on-off switch on the electrical equipment, you turn that off, then unplug it, and so on. So turn off the power. Make sure all electrical apparatus is turned off before you plug it into the outlet. If you follow these guidelines, you will have a safer lab.